Hello, everyone, and welcome to today's Orchestrator meeting. Let's see what we have on the agenda for today. Let's start with Rook. I would say let's start with Rook. We have three topics today. We have OSD creation via storage classes. We have HA proxy, and we have further looking at topic looking into 2022. Other than that, we should probably add to our meeting minutes who actually added topics, because it's for me it's just a bit of a guessing who's actually adding topics. Oh,
I didn't add the topic on HA proxy, but I came to talk about it, if that's helpful.
yes, perfect. Thank you. Okay, let's start with Rook and storage classes. Who wants to take it?
Oh, I guess I put this on there, wasn't it? Okay. Yeah, I think we just need to, I haven't actually thought about this ahead of time, so my bad. But right, we need a way to create OSDs backed by storage classes. So I think that the current device inventory obviously isn't sufficient. There needs to be something else that exposes what the storage classes are named, at least. So I guess probably a new Orchestrator API at storage classes, I guess. I don't know. And that would return things like whatever the storage classes are available in the cluster.
Yes.
They're going to be like EBS provisioning types, probably. I don't think that it makes sense necessarily to like try to make this mean something in a bare metal, like a Ceph ADM case.
No.
I mean, we could say that they're like the device types, SSD and HDD, maybe. Like we could do that.
We have that in the inventory, in the Ceph inventory already. It doesn't really make sense to have yet another API call that returns the same thing.
Yeah. Okay, and then we need a drive group property storage class. Something like that. So that you can actually, and then I think hopefully the existing OSD creation machinery should just work. That's my hope. But probably somebody who understands Rook better and how OSD creation works should like figure out how that works. Because right now, the way the storage classes are implemented now is that they are implemented on the side of the manager module. So we like look at the device inventory and we match those against the storage class. And if they match, then we go trigger an OSD creation. But if we use the storage class, then it's different because there aren't any devices and we don't know whether there are. Hopefully those will just translate directly into a property on the cluster CRD. I think that's how it
don't we have the storage device, storage class set? Yeah? Or was it removed?
What are you looking at?
Let me try to find it in the Rook docs.
Thinking about storage class device sets?
Yeah.
How does that work?
It's so we have a storage section in the CRD, and we have a set where each set can represent a set of OSDs. And inside the set, I mean, each set is like, I think it's just like a bundle of disks, if you want. And we have a volume claim template that we add in the set, and points to a given like storage class. And that's how we just use it to, like, we go through each set, and then inside each set for each volume claim template, and then this is how we create the OSD, essentially. You can have multiple, I mean, inside the volume claim template, you can have many types, which would, and each type can represent, like, if it's an SSD or an OSD or an HDD. And that's how we do data versus metadata drives detection, essentially.
So this would be a one-to-one mapping, right? Like one of those items, one of those device sets would map one-to-one to a.
That's right. Yeah.
And it has to have a count, I would assume, or else you'll just create an.
The count, yeah, the count is at the very top level, so it's inside the storage class device set where you specify how many OSDs you want, right. And then you can divide that up to SSD versus HDDs, and then the resulting is just an OSD, but sometimes it can have like the metadata for while in DB, and sometimes it's just an all-in-one OSD that has everything. And yeah, it's a one-to-one mapping, which obviously in the cloud is really easy to do, but maybe a bit more complex in the case of. I mean, it is easy to do on bare metal if the storage class has disks, then you can pick up any disks. But as soon as you want to play with metadata, then you're going to be picking up entire disks. Or yeah, that's how it will work today, because everything is governed by the size. I mean, if you look at the volume claim template,
yeah,
we have to specify a size, which gives the size of the OSD. So it can be, the size could essentially be the disk, but the size for the metadata should be rather small, which again in the cloud is really very easy to do because we have elastic storage everywhere and everything is dynamically provisioned. So it's easy to ask for EBS to give us like 10 gig. But on bare metal, it's a bit more tedious to ask for low piece of storage, I guess, for metadata. But maybe it's just too advanced as a use case. I mean, not so much, I guess, but the more complex deployment method than just getting the entire disk for the OSD for sure.
Makes sense. Yeah. Yep. Looks good. Okay.
I mean, as soon as
if we can get the storage classes, then we can build the set, and inside the template we can put the storage class.
Yep. Okay. I think that makes sense.
I think we have to use it. I mean, as soon as we are looking into storage classes, we should look into storage class device sets. I think anything else doesn't really make sense.
What's a storage class device set?
Storage class device set.
Is that the device that you're just talking about on the cluster CR?
Yes, exactly.
Yeah. Okay. Yeah, absolutely. Yeah, this seems very straightforward, actually. As long as we just need to make the validate function on the drive group require that count accompanies the storage class if it's set, or else it's invalid. And then it should just directly map to a device set or whatever in the cluster CR. Right?
Yeah, and for now, I think we only need to have a single set. You can get multiple sets if you want to have different properties for the OSDs, for example. Let's say you want to have a set of OSDs that are encrypted and a set that where OSDs are not encrypted. This is how you would use sets, I guess. But right now, you only have a single set with the count and then maybe multiple volume claim templates inside it. If you want to have a metadata block device.
Yeah. Yeah. Well, yeah. There'd be one per drive group. If the user creates different drive groups for whatever reason, for example, 2 different source classes or whatever, then that would be 2 devices.
Yeah. Also.
Yeah. Okay. And the get storage classes property on the orchestrator would just enumerate all of the storage classes available in the cluster and just return all of them, presumably. Are there any like properties there? Like if you're enumerating storage classes, you don't know like anything really about them, right? Like is there like even a description or anything, or is it just a name?
Yeah, have a look at the link I pasted into the meeting minutes in the first link I pasted. So storage classes have a name, a provisioner, a type, a reclaim policy, volume expansion, and mount options. And
I guess you can return like reclaim policy and volume expansion flag.
The provisioner as well. I think that's really the one that makes most of the sense. Yeah. It's really, I mean, it's the only thing that is not generic, actually. It's the most precise thing you can get about the backend.
Yeah. Okay.
Let's try to map the storage class Kubernetes resource in a class in the orchestrator.
Yeah. Yep. Okay. And then there'll be a CLI command to list them. I think that's basically it. Or it's a CLI user experience. And we should probably talk to somebody on the dashboard team about how to present that on the dashboard, because it's not obvious to me what is intuitive.
Don't we have that already in OCS?
Oh, on the OCS dashboard, maybe?
Yep.
I've never actually seen that before. So
probably. Yeah, we do have that selection.
Yeah, so maybe we model after that. Okay. That's it.
Okay. Blaine, up to you.
Yeah, I had this on the agenda for last week, but we didn't get to it before I had to jump to the huddle. I see that there are some notes from last week. But yeah, I wanted to at least like kind of briefly bring it up again. Like one of my concerns is I think there have been like twice in the past year that something has changed in a Ceph release that has broken something for Rook, and we've had to scramble to get a fix out for it.
Yep.
I know Ceph did some work recently to try to help us catch those things, having like nightly jobs that test upgrades to like Octopus and Pacific master branches. But I also want to make sure that it is at least somewhere on Ceph's radar to be able to run tests like that, or to run validation before a Ceph release goes out. Because there are times like currently some of the stuff for NFS Ganesha is changing, but we know about that and like are working to make sure that the changes in Ceph don't impact negatively.
Blaine, do you have a list of breakages that Ceph caused?
I don't. There was one recently with the file system setup. So something changed in Ceph MDS or Ceph file system recently that caused Rook to fail to be able to deploy file systems. And I think one of the other things was when Ceph Volume abruptly dropped support for partitions, I think. Maybe that was a little over a year ago. Seb might remember
Yeah, this one
more.
too, I guess. Yeah. And I think the most recent one is that all of a sudden one container image just disappeared from Quay. And I guess our entire CI was down because the image wasn't there anymore. We just never got any really explanation on why the image was deleted. But this is kind of a concern too, because nothing was broken for Rook at least. But then this image was deleted.
Now we really have to avoid these bracketers, these unannounced bracketers. It screws everyone's workflow up. How can we prevent these bracketers?
I think in a sort of long-term view, I think it would be nice to get a CI that would run for like Ceph PRs on a basic version of Rook. But outside of that, I think more in the short term, it would be easy to, before any Ceph release, either allow us to run a test suite using a release candidate image, or to have the Ceph project do that themselves as part of the validation process for publishing a Ceph release.
Yeah, I guess if Yuri can just add us for verification for QE testing or just before releasing Rook Axe, and then we just go ahead and say, okay, we have tested with the tip of specific or whatever, and it's not breaking for us, so we're good to go. I think that should be simple enough.
That's a good idea. I have a question though also, what is the key gap, I guess, with what we're doing right now, where we have this, because we have a test suite, this Orch Rook suite that we're running now. I guess we're only doing it on master, so we're not doing it on Pacific yet, but that should cover most things, right? We're running against Rook master or Rook tip or whatever, and also one or more stable releases of Rook. That's just a smoke test, I guess, right now, but that should catch most things, right?
I think it's fine. I think it's fine, and also just I've added much more tests in our CI to test upgrades between stable versions and running on master and latest tip of Pacific, tip of Octopus 2. So we should be covered on our side as well with that regard.
Should we add an upgrade?
But yeah, I think
upgrade test there.
Which upgrade? The upgrade of the operator or Ceph?
Yeah, the Rook tests are deploying whatever the current version of Ceph is, the tested version of Ceph with 2 different versions of Rook, but we could have it deploy an older Ceph version, and then upgrade to the current version, and let Rook do the upgrade and make sure Rook upgrades work.
We do that already in our CI. Okay. So yeah, I think we're good.
Okay.
Yeah. But yeah, I guess I'll just go and ask Yuri about that if we can be included, because normally it should always be okay. And I mean, those occurrences were pretty rare, but I think it would be good to kind of establish better the communication channel too. So I'll just ask him.
Which means what would be great from someone from the Rook team to actually own the rook suite, I guess. That's
What
a bit
is the rook
far-fetched, right?
suite? Can you repeat? What is the rook suite?
The rook suite is the Sage
The one that's like at the top.
Orch/rook suite.
Orch/rook, yeah.
Yep.
What did you say, Sebastian? No, what about it?
If someone from the rook team would own that rook suite.
Or at least review it, I guess. Maybe.
Yeah, review it, approve changes. Maybe not merge it or develop it, but at least
we could
be
put a
part
I
of.
think we do review already. We do that already. I think when Sage sent the PR, we chatted quite a lot about it too and reviewed. So that we do, I guess.
But I could add you as a code owner or whatever. So that is there a GitHub group for Rook developers?
No.
I can do that.
I wonder if we could figure out how to chain the pipelines together at all to build a Ceph image and then somehow run all of Rook's integration with that image.
You mean a Ceph image? Right?
Yeah. I'm not sure exactly what the best way to do that would be.
We kind of do this already, I think, with the latest jobs I created. We deploy Rook Master with Ceph Master already.
Mm-hmm.
And we also deploy the tip of Octopus and Pacific. And we test the upgrade from current stable Pacific to tip of Pacific, and same for Octopus.
Mm-hmm.
I feel like we're pretty covered.
Okay, sounds good.
Okay. Guess that's done. Blaine, are you happy?
Yes, very. Thank you.
Okay, Kyle. Let's talk about HA proxy and IPVS.
Sure. So one of the things I had kind of sketched out on the Etherpad some thoughts, but one thing that I would like to be able to do is be able to offer the current either the current strategy, which is the HA proxy based approach, which would be like a L7 strategy, or like a L4 strategy, which would use IPVS instead of HA proxy. And what I always say operators, but now that's an overloaded term. But what Ceph users would get from that is they would get scalable read traffic because it could do IPVS can do direct server return. So you can have kind of a number of RGWs, and at least for GET requests, the size of the request that's coming in through the VIP, which is always going to be a single node in this case, is small, but the response is usually big. And with HA proxy, at least with L7, the response always goes back through the node where the VIP is, and so you're kind of limited to the throughput of whichever node is the acting primary HA proxy. With the IPVS, you can configure it to do a direct server return. So while the GET request comes in through the server that has the VIP, the response goes directly from the RGW back up to the client, and so you can have GET traffic at least that takes up is higher volume than you might otherwise be able to support with a single node. So that was kind of the next step. I do think it's still good to have HA proxy in there because some people prefer to have a L7 proxy because there are some things you can do in HA proxy around, like if they want to terminate TLS at the load balancer, sort of like Lua scripts or access monitoring or something, they can do that in HA proxy. I know that there's been a couple people at times that have done like request rate limiting in HA proxy. So I think it's still valuable to have that as an option, but to complement that with an additional option for like L4 based load balancing. If that makes sense. So the let's see, I had created kind of a Etherpad where I started to sketch this out. So we would reuse the Keep Alive D stuff, and instead we would just change out the HA proxy effectively for programming IPVS. Which one? So it would have a little bit different options than HA proxy because, of course, like you can't terminate TLS, so there would be no SSL cert because it's all L4. And there are, maybe some different settings that we want to surface in terms of the way that you do IPVS. But yeah, there's a good article that I posted in the Etherpad from Cloudflare. I think one thing that we want to be cognizant of is the way that IPVS does direct server return is by rewriting the source IP address, so that the server, the destination IP address from or the destination MAC address, from the VIP's MAC address to the MAC address of the server that will end up serving the traffic. And that only is going to work over if the machines are over the same L2 network. So if all the machines that are participating in the load balancing are in the same subnet, the way that Cloudflare and other places get around that, because sometimes they might have a Ceph cluster that is like on 3 racks or something, and each rack has its own like /24. You want to be able to have traffic come in one rack and then come out another rack. They kind of set up tunneling, and that's what the UDP over foo or foo over UDP tunnels is. So it's like setting up a tunnel to be able to send the rewritten data or the rewritten Ethernet frame over that, and then it'll come back out directly back to the source IP. So that's an additional bit of complexity. I don't know if we want to take that on as sort of an MVP, but I do think it's something that we do see out there where people have 3 racks and they each have their own subnet. But yeah.
Interesting.
Fascinating.
So Maglev is the Kubernetes bare metal.
So
thing?
Maglev is like a hashing method that made its way into Linux kernel for IPVS. Okay. The thing that does similar functionality for Kubernetes is called MetalLB.
There you go. Okay.
Yeah. So and that actually has 2 different strategies. We're doing like the easier one first, which is the IPVS. They also offer like a BGP based one, but I think if we're working up from like the Maslow's hierarchy of needs, we'll start with like, we have HA proxy, then IPVS, and then we can figure out, something more sophisticated later for people that have like need to be able to scale write traffic into the cluster as well. And I have some thoughts about at least how we could potentially do that, but I think this is a good next step in terms of like adding load balancing functionality to Ceph ADM. We did do some documentation that even made it into the downstream RHCS4 docs on kind of some of the specifics of the IPVS. I think we probably need to update them because it was done a little while ago. But we can use that as kind of a starting point in terms of like the way that we need to poke the Linux kernel ones to set up these sort of things. So to what extent it would be useful for me to try to get kind of like the list of commands for the actual IPVS configuration, I can expand upon that in the Etherpad in terms of like the actual implementation. But I would defer to one of you that are more familiar with the Ceph ADM code base.
Mm. I think maybe that's a topic that we can look into for Ceph beyond Quincy. Sage, do we already have a code name for
I
R?
would just call it L4 load balancing for Ceph ADM or something.
Yep. Okay, Sage left. Perfect. Yeah. Let's put it into a track issue. I did it already, and that might be a topic that you can look into for the Ceph version that's coming after Quincy, I guess.
Post Quincy. Okay.
I don't think that we will be able to get it into Quincy at this point.
Yeah, that's
I mean, Quincy is going to be released when on early next year.
Mm-hmm.
Until then, we have to do a lot of cleanup with the existing functionality.
Okay, I just wanted to plant the seeds for it. So,
yeah.
Yep. If I'll continue to elaborate on the Etherpad, and I see you have the tracker. If it's useful, then we can make a card on the community Trello or whatnot for like the post Quincy planning.
Yeah. What in general is what would be great to know if someone is already deploying LCW with IPVS in the upstream community.
I do know that we probably have some customers that are doing it. I will, in particular, I know there was one that was in the process of deploying it right now, so I can get some more details if that's useful.
Mm-hmm. Definitely. Okay. Yeah, thank you, Kai. I don't think we can
Thank you.
decide anything right now. Yeah, let's take it as an action item. Definitely for the next major version of Ceph. And the last topic I had in mind for today was if there are any other topics that we should look into for Ceph beyond Quincy. We have the Trello. No, we have the Trello board. Already contains a few items. Let me try to find the link. Yeah, we have the Trello backlog, Ceph backlog here. And would be great to have ideas what we really need to do for Ceph, VM, and the orchestrator beyond Quincy. I don't think it does make sense to go over the topic just yet, but at least it would be great to understand what else might be on the plate beyond Quincy. Okay. Do we have anything else for today? Okay, let's call it a meeting. Have a nice week, and let's sync up next week.